Hello my dear students, in this video we are going to continue with non-linear data structures. Let us have introduction. Non-linear data structure is a data structure in which each data item is linked to several other data items. There are two pros and one cons. Pros and cons are nothing but these are the advantages and disadvantages. Let us continue with the first pros. Uses memory efficiently as contiguous memory is not required for allocating data items. The second pros is the length of data item is not necessarily be known prior to allocation. The con is overhead of the link to the next data. Now let us study about trees. A tree is a data structure that consisting of nodes organized in a hierarchical fashion, that is in a hierarchical order. So as we are going to go down in the tree, you will find it is growing. Here on the top we have got a root node, and on the top we have got ancestors, and down below the root node we have got descendants, and we have got different labels in the trees. Let us study each one of them using the terminology. So let us continue with the first terminology. What do you mean by node? Node is a structure which may contain a value, a condition, or represent a separate data structure. Parent node. A node that has a child is called the parent node, or we also call it as ancestor node, or it is a superior node. Leaf node. It is also called as terminal node, or we call it as child node. Nodes that do not have any children are called leaf node. Height of a node. The length of the longest downward path to a leaf from that node is called as height of a node. Depth of a node. The length of the path to its root is the depth of a node. Root node. The topmost node in a tree is called the root node. An internal node or inner node. Any node of a tree that has child nodes and is thus not a leaf node is called internal node. Next, subtree. A tree consisting of a node and all of its descendants in a tree. Let us continue with the binary trees. A binary tree name itself suggests that it is a tree in which each node has at most, that is the maximum, two descendants, means two leaf nodes. A node can have just one, but it can't have more than two. So it can have one node, but it should not cross more than two nodes. Here in the diagram you can see 7 is the root node that consisting of two child nodes, that is 10 and 5. In turn 10 has got two more child nodes, 15 and 8. Here 5 has got two more child nodes, 6 and 3. Here 15, 8, 6 and 3 are called as leaf node because they do not have any further children. And here 10 and 5 is acting as the parent node to 15, 8, 6, 3. And here 7 is acting as a root node to both 10 and 5. So this is the parent to both 10 and 5. Now we will study complete tree. A tree in which each leaf is at the same distance from the root. That is, all the nodes have maximum two subtrees. Graphs. A graph is a set of vertices and edges which connects them. A graph is a collection of nodes called vertices, and the connections between them is called edges. Here in the following diagram you can see the graph with the 5 vertices and 7 edges. The edges between A and D and B and C are pairs that makes bidirectional connection. You can see here it is double-ended arrow. Here also between A and D double-ended arrow. Here you can see we have got total 5 vertices. A, B, C, D and E are the vertices and 7 edges. So from A to B 1 edge and double-sided B and C 1, 2, 3, 4, 5, 6 and 7. Here total 7 edges we have. That's all in this video. Thank you very much for watching this video. We will see you in the next video.